today I'm going to discuss about graphs of inverse functions. So we have here an important theorem. The theorem states that if f has an inverse, then the graphs of y is equal to f of x and y is equal to f inverse of x are reflections of one another about the line y is equal to x. That is, each graph is the mirror image of the other with respect to that line. So to that line y is equal to x. So to understand more on the theorem, we have here an illustration. So we have an xy plane, and we also have y is equal to x, okay? The theorem states that the graphs of y is equal to f of x and y is equal to f inverse of x are reflections of one another about the line y is equal to x. So suppose we have a point A and B. This point lies in the graph of y is equal to f of x. Okay, so by the theorem, we expect that there is a point that is a reflection to this point also, and that point lies on the graph of the inverse function y is equal to f inverse of x, this one. Notice that the distance from this point going to this point, okay, is just equal to the distance from this point going to this point. So this means this point is just a reflection of this point with respect to the y is equal to x. Okay? So notice that the points A and B and B and A are reflections about y is equal to x. Okay, so another example. Suppose this is the graph of y is equal to f of x, and this is also the graph of y is equal to f inverse of x. Since this one is just a reflection, so all we have to do is just to flip the graph, okay? So the graph of this function is just the same as the graph of this function, only that this one is being flipped, this is a reflection of this graph. So again, this point here, A and B, that lies on the graph y is equal to f of x, okay, has a reflection, and that reflection is the point B and A that lies on the graph of the inverse function. So the graphs of f and f inverse are reflections about y is equal to x. Okay, so this is also one way to determine if the graph of that function is a graph of its inverse function. Okay. So we also have these another examples. Suppose we have y is equal to 2x and y is equal to 1/2 x. Okay, then we can say that 1/2 x is an inverse function of 2x if we can show that the graph of this function is a reflection of the graph of 2x about the y is equal to x. And we clearly see that 1/2 x, the graph of 1/2 x is a reflection of the graph y is equal to 2x. So you just pick one point on this graph, then make a distance from this point going to the line y is equal to x, and that distance must be equal to the distance from this point going to this y is equal to 2x. Okay? So another graph is y is equal to x cubed. Now we know that the graph of y is equal to x cubed, okay, is a reflection of the graph of y is equal to x raised to 1/3 about the line y is equal to x. Since we have already discussed and have shown that these two are inverse functions. Okay, so we clearly see that the two functions are what? Are inverse functions, because this one is just a reflection of this graph with respect to y is equal to x. Okay, so another example is this function y is equal to the square root of 3x minus 2. Okay, if you want to sketch the graph of this function using your hand, you can sketch this one by transformation. Then you can come up with a graph like this. So this is the graph of y is equal to square root of 3x minus 2. Okay? Then after that, sketch the graph also of the inverse function. Or if you want to know what is its inverse, then you solve it. Okay? Then, since you know that this is already a an inverse of the given function, then you can also sketch that one uh, easily because you know already the graph of the given function, and by the theorem it should be a reflection, okay, of the given function with respect to y is equal to x. So if this is the graph of y is equal to square root of 3x minus 2, you just make a graph that is a reflection of this graph about y is equal to x. So you graph this one like this and make a reflection graph, okay, with respect to y is equal to x. Okay, so we have here an illustration on how we sketch the graph of y is equal to 2x or f of x equal to 2x and its inverse, which is equal to 1/2 x, okay? Because sometimes we need to sketch the graph manually, okay? So I have here a video showing you on how to sketch the graph of these two functions. So here we are going to show that the two functions 2x and 1/2 x are inverse functions. But before that, let us first graph the function y is equal to x. Okay? So our method here to determine that the two functions are inverse of each other is graphical method. So let us graph the function y is equal to x. So this is the graph of y is equal to x. And also the graph of 2x. So this is the graph of 2x. Then the next one is the graph of 1/2 x. Okay. Now, okay, as you can see, this graph is a reflection of this graph with respect to the y is equal to x. So let us show some points on each graph. So we have, we'll make it as -4, -3, -2, -1, 0, 1, 2, 3, and 4. Okay, for y is equal to 2x, let us also add points. So we have, we'll make it as -4, -3, -2, -1, 0, 1, 2, 3, and 4. Okay, so these are the points. So for the graph of y is equal to 1/2 x, so let's add some points. So we make it as -4, -3, -2, -1, 0, 1, 2, 3, and 4. Okay, so as you can see, we have here points. Okay, say that the functions are inverse functions. Let us see if the point here, let's say this point 2 and 1, let us compare this point to this point. Now, by the concept of inverse function, this point must be 1 and 2 because if this is our given function, then it has an element in the domain which is 2. So this will become the element in the range of the inverse function, which is correct. How about this point? This is 4, 2, and this is 2, 4. How about this point? This is -2 and -1, so we expect that is -1 and -2. So we can say that the function y is equal to 2x is an inverse function of y is equal to 1/2 x, or the y is equal to 1/2 x is an inverse function of y is equal to 2x. Okay, so we have here a screenshot of the video. Okay, so we recall that y is equal to 2x and this is y is equal to 1/2 x. So we clearly see that the two functions are inverse of each other because This function is this graph is a reflection of this graph with respect to y is equal to x. Okay, so again, if you want to sketch the graph of the given function, even if you will not use a graphing calculator or um, any software to sketch the graph of the given function, you can still sketch the graph. For example, this 2x here. So you want to sketch the graph of 2x. Now, this 2x is equal to, is a form of mx plus b form, right? So mx plus b, where b is 0 in this case, and m, which is the slope of the line, which is 2. Okay, and we have already the concept that graphing a line is we can use the b and the slope. Okay, so since the b is, in this case, the y-intercept is 0, so you start from 0. Okay, you start from 0, and since the slope is 2, that means you rise 2 units, okay? And since 2 is just equal to 2 over 1, that means you rise 2 units and you run 1 unit to the right because the slope is positive. So the line um, must lean to the right, okay? So for example, in this case, 2x, you want to sketch this one. So you start from the y-intercept 0, you rise 2 units, 1, 2, you run 1 unit to the right. So this is now the point 1 and 2. Then you can continue. You rise 2 units, 1, 2, then you run 1 unit to the right. Okay, so you have this line already, and to continue the line to this side, you can, if you rise 2 units, then you can also fall 2 units downward. So 1, 2, and there is another grid here. So you can also run to the left so that we can form a line that is leaning to the right. So this is now the line of y is equal to 2x. Okay. So how about this one? 1 half x. So 1 half x, you have a slope which is 1 half, and the y-intercept is 0. So you start from the y-intercept is 0. Then you rise 1 unit because of this. The numerator is 1. And you run 2 units to the right because of the denominator 2. So from here, you rise 1 unit, you run 2 units. So 1, then 1, 2. Okay? Then you continue. 1, you rise 1, then you run 2 units. 1, 2. So this is now the point, which is 4 and 2. Then we can connect the points, okay, to form a line. But again, we do not know the line in this part, so we can fall this point 2 units downward. So 1, by the way, 1 unit because of this one. So 1, then you run 2 units because of this denominator. So 1, then you run 1, 2, okay, to the left in order for us to have a line leaning to the right. So this is now the graph of y is equal to 1 half x. Okay, so the point here is even if you will not use a calculator, graphing calculator, still you can sketch the graph of the given function by applying the methods that we used, the table of values, and also transformation method. Okay. So for your exercise, um, if you want to practice more, so you can answer this exercise, finding the inverse of a function. First, you have to sketch the graph of square root of x minus 2. Then use the graph of f of x to sketch the graph of f inverse. Okay. Once you have sketched the graph of f of x, that's the time you can sketch the graph of f inverse using the theorem that the graph of the f inverse must be a reflection of the graph of f of x. Then find an equation for that inverse. Okay, so if you want to know your answer is, if your answer is correct or not, you can show your answer and I can give feedback to you. Okay, so thank you so much. Hope you like this video and don't forget to share the learning that you've got from this video. Thank you once again and God bless.